It Didn't Start With You. Chapter 2, Video 4, continued. Epigenetics, Inheritance. It's only recently that scientists have begun to understand the biological process that occurs when trauma is inherited. To learn more, researchers have turned to animal studies. Because humans and mice share a strikingly similar genetic blueprint, 99% of the genes in humans have counterparts in mice. These studies provide us with a lens through which to view the effects of inherited stress in our own lives. This research is valuable for another reason. As generation in mice is approximately 12 weeks, multi-generational studies can produce results in relatively short time. A similar study conducted with humans could take as long as 60 years. Chemical changes in the blood, brain, and sperm of mice are now being linked to behavioral patterns such as anxiety and depression. In later generations, studies performed on offsprings, for example, have shown that traumas such as stress of maternal separation cause genes expression changes that can be traced for 3 generations. In one such study, researchers prevented females from nurturing their pups for up to 3 hours a day during their first 2 weeks of life. Later in life, their offspring exhibited behaviors similar to what we call depression in humans. The symptoms seemed to worsen as the mice aged. Surprisingly, some of the males did not express their behaviors themselves, but appeared to epigenetically transmit the behavioral changes to their female offspring. The researchers also discovered altered methylation and gene expression changes in the stressed mice. Among the genes involved was the CRF2 gene, which regulates anxiety in both mice and human. The researchers also found that the germ cells, the precursor egg and sperm cells, as well as the brains of the offspring, were affected by the stress of being separated from their mothers. In another experiment with rats, offspring that received low levels of maternal care were more anxious and more reactive to stress in adulthood than were the rats that received high levels of maternal care. This stress pattern was observed in multiple generations. It's common knowledge that infants who have been separated from their mother can experience challenges as a result. In studies involving male mice, pups that were separated from their mothers exhibited lifelong increases in stress, susceptibility, and generated offspring that exhibited similar stress patterns over several generations. In one of those studies conducted at the Brain Research Institution of the university, researchers subject male mice to repeated and prolonged periods of intense stress by separating them from their mothers. Afterwards, the traumatized mice exhibited a number of depression-like symptoms. The researchers then had the mice reproduce and discovered that the pups in both the second and third generation showed the same symptoms of trauma despite never having experienced it themselves. The researchers also discovered abnormally high numbers of microRNA, genetic material that regulates gene expression, present in the sperm blood of the traumatized mice. The abnormal levels of the microRNA were also discovered in the blood of the mice from the second generation. Although mice in the third generation expressed the same symptoms of trauma as did their fathers and grandfathers, elevated numbers of the microRNA were not detected, leading researchers to speculate that the behavioral effects of the traumatic event can express for 3 generations, but perhaps not beyond. With the imbalance in microRNA in sperm, we have discovered a key factor through which trauma can be passed, explains Isabel, a co-author of the study. She and her team are currently studying the role of the microRNAs in trauma inheritance in humans. In a later study published in 2016, her colleagues were able to show that trauma symptoms could be reversed in the mice after they lived in a positive, low-stress environment as adults. Not only did the mice's behavior improve, they also experienced changes in DNA methylation, which prevented symptoms from being transmitted to the next generation. The implications of the studies are particularly significant. In later chapters, we'll learn to create positive images and enriching experiences that can help reverse stress patterns that may have affected our family for multiple generations. What makes the mouse research so intriguing is the science can now substantiate how the challenges experienced in one generation can become the legacy transmitted to the next. In a study involving the offspring of stressed male mice conducted at the Emory University School of Medicine in 2013, researchers discovered that traumatic memories could be passed down to subsequent generations through epigenetic changes that occur in DNA. Mice in one generation were trained to fear a cherry blossom like scent called. Each time they were exposed to the smell, they simultaneously received an electric shock. After a while, the shocked mice had a greater amount of smell receptor associated with the particular scent, enabling them to detect it at a lower concentration. They also had enlarged brain areas devoted to those receptors. Researchers were also able to identify changes in the mice's sperm. The most aspect of the study is what occurred in the next two generations. Both the pups and the grandpups were exposed to the blossom odor, became jumpy, and avoided it, despite never having experienced it before. They also exhibited the same brain changes. The mice appeared to inherit not only the sensitivity to the scent, but also the fear response associated with it. Brian Diaz, one of the researchers of the study, suggested that there's something in the sperm that is informing or allowing the information to be inherited. He and his team noted abnormally low DNA methylation in both the sperm of the father's mice and the sperm of the offspring. Although the exact mechanism for how a patient's traumatic experience gets stored in the DNA is still under investigation. Diaz says it behoves ancestors to inform their offsprings that a particular environment was a negative environment for them. This particular study provides compelling evidence for what the researchers term transgenerational epigenetic inheritance, the notion that behaviors can pass from one generation to another. When I work with families in my practice, I often see recurring patterns of illness, depression, anxiety, relationship struggles, and financial hardships. Always feel compelled to look deeper. What unexplored event in a previous generation drives the behavior of the man who loses all his money at the racetrack, or the woman who chooses to be intimate only with married men? How have their genetic inheritance been influenced? Diaz and his group are hoping to carry our further work to determine whether similar effects can be seen in the genes of humans. Until the data is examined in human studies spanning multiple generations, the current research with animals certainly asks us to pause, consider how we were born, sharing the stress of our parents and grandparents. In a 2013 study involving female rats, published in the Biological Psychiatric, discovered that even relatively mild stress before conception and pregnancy was significant enough to affect offspring. Several of the rats were exposed to minor stress, such as changes in temperature, as early as 45 days after they were born, which is equivalent to adolescence in humans. Remarkably, the effects were measurable in the next generation. Focusing on the CRF1 gene, which encodes a molecule involved in the body's response to stress, the researchers detected increased amounts of molecule product of this gene in the brains of the stressed female rats. They also discovered significantly increased concentration of the same molecule product in the eggs of the stressed females and also in the brains of their offspring, demonstrating that the information about the stress experience was being transferred to the eggs. The researchers insist that the altered behavior in the newborn rats is unrelated to the type of parenting the pups received from their mothers. This particular study suggests that even if humans receive supportive parenting as infants, we are still the recipients of stress our parents experienced before we were conceived. In the next chapter, we'll explore how siblings born of the same parents may inherit different traumas and lead contrasting lives despite sharing a similar upbringing. In a 2014 study with rats at the University of Lethbridge in Canada, researchers examined the effects of stress on pregnant mothers and its influence on preterm births. The findings revealed that stressed mothers delivered preterm babies and bore daughters who also had shortened pregnancies. The granddaughters experienced even shorter pregnancies than their mother. What surprised the researchers most occurred in third generations. Granddaughters of stressed grandmothers had shorter pregnancies even when their mothers had not been stressed. A surprising finding was mild to moderate stress during pregnancy had a compounding effect across generations. Thus, the effects of stress grew larger with each generation. Epigenetic changes are due to non-coding microRNA molecules. These findings could have implications for humans who are at risk for pregnancy or childbirth complications due to stress. Given that a generation in humans is approximately 20 years, the result for human studies spanning multiple generations are still pending. However, with the research demonstrating that stress can be transmitted through at least 3 generations of mice, the researchers surmise that children born to human parents who experience a traumatic or stressful event would also likely pass the pattern down not only to their children but to their grandchildren as well. Uncannily, the Bible, in Numbers 14:18, appears to corroborate the claims of modern science, or vice versa, that the sins or consequences, depending on which translation you read, of the parents can affect the children up to 3rd and 4th generation. Specifically, the New Living Translation states, "The Lord is slow to anger and filled with unfailing love. Forgive every kind of sin and rebellion, but he does not excuse the guilty. He lays the sin of the parents upon their children. The entire family is affected, even children in the 3rd and 4th generation." As new discoveries in epigenetics are revealed, new information about how to mitigate the transgenerational effects of trauma could become standard practice. Researchers are now finding that our thoughts, inner images, and daily practices such as visualization and meditation can change the way our genes express. In an idea, we will examine it in more detail in the next chapter.